Okay, and this part we're going to introduce 802.11 protocol. IEEE 802.11 is first wireless network standard, and it's established by IEEE at 1997. Several standards have derived from 802.11. From this picture, we can see we have 802.11b, .11a, .11g, .11n, .11ac, and .11ax. And the latest one is 802.11x. Okay, and all of them are using 2.4 gigahertz band or 5 gigahertz band. Okay, and for all these protocols, let's see. At the physical layer are the standards we have mentioned. You can see the rate of them is increasing, right? From maybe a half megabps to even until now 802.11ax supports 9.6 gigabps per second. Okay, and at the MAC layer, we have multiple standards to maybe support different functions. For example, 802.11e, which focuses on the QS, and for example, 802.11i, we are very familiar with it. It's about the security of the wireless network, right? And 802.11r focusing on the RMAN standards, and 802.11s about the mesh wireless network architecture. Okay, about the 802.11 standards, let's see the frame formats. In this picture, you can see this is a frame, and in this frame, it have multiple items. For example, the first part is frame control, right? It's about the actually to some parameters to control the frame, right? And the next part is a duration ID, records the network allocation vector, right? And next is destination address, source address, and receiver address. Destination address is a receiver. The station hands over frames to the upper layer protocol for processing, while the source address is quite easy to understand, which represents the source of the frame. And the receiver address is where the station responsible for processing a frame. Okay. Next is sequence control field, regroups frame fragments and discards duplicate frames. Okay, and all these fields we have just mentioned, the length is 2 bytes. Okay, next is transmitter address. Transmits frames to the wireless media interface. Okay, the length is 6 bytes, and the last field is frame check sequence. We call it FCS. Allows the station to check the frame integrity, which length is 4 bytes. Okay, this is about the format of the frames. And then let's see about the 802.11a, b, and g. These 3 standards. The operation band of them, only 802.11a is using 5 gigahertz band. The other 2 are using 2.4 gigahertz band. The channel bandwidth is different. 802.11b's channel bandwidth is 22, while the other 2 are 20, right? And the physical layer technology they are using, for example, 802.11a and .11g is using OFDM, right? And the .11b is using DSSS and the CCK. Okay, the rate of them, 802.11a supports 54 Mbps, right? .11g is the same, while .11b has a slower rate, which is 11 Mbps. Okay, next let's see the key technologies. .11g's key technology is 64 QAM. Well, the advantage of them, let's see it. The advantage of .11a is higher rates than .11b, right? From the theoretical rate, we can see them, right? Of course, .11g also have a greater rate than .11b, and the capability of .11g is good. Of course, it capability with .11b. Okay, since you are using the same band, right? Okay, and the disadvantages of .11a is incapability with .11b, while .11b's disadvantage is very obvious, right? The slow rate and prone to interference. Okay, after seeing the features of these three standards, then let's see the door band and the door mode. Door band means one AP can support two different bands. 2.4 GHz and 5.8 GHz is supported at the same time. This is called door band. Where door mode means one AP supports two modes. For example, it supports 802.11a and .11b at the same time. So this kind of APs can set out two different kinds of signals and allows two different types of WLAN devices to connect. Of course, as we know, for example, some terminals or some clients only support .11a or only support .11b. So in this situation, both of these types of devices can connect to one specific AP. It's very convenient, right? Okay, and next, let's see 6 features of .11n. First is a high bandwidth. It has a bandwidth of 300 to 600 megabps. It's higher than the standard we have just introduced, right? And the data throughput of more than 100 megabps, which are equivalent to those of maybe 100 Mbps cable networks, right? In this way, it can satisfy services that require high bandwidth, for example, IPTV, right? And next is a wide coverage. 802.11n uses groups of independent intelligent antennas to form an antenna array. Okay. In this way, it dynamically adjusts the wavebands to provide stable signals for the users, and in this way, we can also reduce the interference. That allows the coverage of .11n to be more than 6 times that of .11g. Okay, and next is high-density connections. This standard allows more users to connect and provide higher bandwidth, making it more suitable for high-density connections. Okay, next is about the penetrability. This standard .11n adopts the MIMO technology that allows better signal penetrability. In complex environments, it has fewer blind spots. What's more, it simplifies preliminary engineering service and reduces devices, bringing down networking cost. Okay. Next feature is stability. Thanks to the MIMO technology, at the same time, of course, it has improved the penetrability and it have improved the stability of the network. Okay, the last is capability. 802.11n is compatible with .11a BG devices, so the capability has been improved a lot, and we can protect the previous investments. This is features of it, and let's see some technical features of 802.11n. First is a block acknowledgement. Multiple frames are handled by one ACK frame. And next is a firm aggregation. Multiple firms are aggregated into one. Next is Shogi. The interval between firms is shorter compared with other standards. Since the interval is shorter, so we can use the interval, or we can use these parts to carry more information, carry more packet, right? And the bandwidth is 40 megahertz. The bandwidth 40 means that the channel are 2 times wider. And since the channel is wider, so we can allow 2 times the traffic supported by other standards to go through this channel. Okay, and the next is a MIMO. MIMO is a core feature of .11n of these standards, and OFDM is also a core feature of it, allowing a rate of 54 Mbps. Okay, and about these two technologies, in the following course, we will introduce them in detail. Okay, and next, let's see what is 802.11ac. This is another standard. 802.11ac is a standard developed by the IEEE. It features 5 GHz bandwidth and 1000 Mbps rate. It's commonly known as 5G Wi-Fi. So from the numbers here, we can see that the bandwidth, right, and the rate has improved a lot. Which bandwidth is 160, and it supports more MIMO spatial streams, which is 8. The downlink multi-user MIMO up to 4, and the high density modulation of 256 QAM is also supported. So it has improved the bandwidth, have improved the rate, right? Okay, at this page, let's see some features of .11ac. First is a non-interruptive and extensible. .11ac is compatible with .11n and even older devices. It supports transparent connection. So it means that it's not only compatible with .11n downwards, but even serves as a sensor to detect unauthorized .11ac devices. New connections can be converted to standard connections later. And the second feature is that 1000 Mbps Ethernet ports. APs are usually connected in the wireless and the dual-band modes. So a single port is insufficient for 2 .11ac RFs. Therefore, we have 2 Ethernet ports are used. So what's more, and the 1.3 Gbps throughput is unlikely to mount much pressure on the ports because the actual throughput is supposed to be less than half of the peak value. And the third feature is called dense deployment. Some believe that higher throughput automatically results in fewer APs, but actually it's not. Wider channels are more like proactive RFs, and the demand for capacity is growing, so even we use .11ac, we need more APs. Okay. The last feature is called reinforced management functions. .11ac management function improve the performance and value of the standards. Therefore, in addition to the improvement in throughput and stability, we also need to take into consideration the IT management efficiency and the overall costs during the use of the wireless network. After seeing the features next, let's see some differences between .11ac and .11n. First is the bandwidth. It's very obviously .11ac has a higher bandwidth, which is 80 or 160 megahertz bandwidth, right? And next, when we see the band they're using, .11ac only use 5 gigahertz band, while .11n uses 2.4 or 5 gigahertz bands. Next is about the modulation. .11n uses BPSK and 64 QAM, while .11ac uses 256 QAM. Okay, and .11n supports multiple types of explicit beamforming, while .11ac only supports NDP explicit beamforming. And about the spatial stream, .11n supports 4 spatial streams. .11ac supports up to 8 spatial streams. .11n uses SU MIMO, while .11ac uses MU MIMO. And .11n supports MAC layer aggregation, while .11ac supports even reinforced MAC layer functions. Okay, this is the difference between them. And next is the latest standard, which is called .11ax. .11ax uses 2.4 and 5 GHz bands at the same time. It's compatible with .11a, BG, N, and AC. It uses OFDM-A for uplink and downlink. And it can offer shorter delay to the users. For the model, it uses MU MIMO for uplink transmission. It also offers shorter delay and greater capacity to the users. And it supports WPA3, which can offer more secure network use. And next is spatial reuse. We call it SR. And the modulation is 1024 QAM, which indicates higher transmission rates. This is about the features of AX. And compared with .11ac, let's see. The rate is 38.6% higher, thanks to the modulation type. And the multi-STA transmission technology, bidirectional MU MIMO and OFDM-A are supported to improve the channel utilization in multi-STA scenarios. Next is called anti-interference. The BSS color and dynamic CA thresholds reduce signal interference during data transmission. And lastly is about the power saving. The self-negotiated power saving management technology reduces air interface contentions and extends the service life of terminal batteries. So for these features, we can see that .11ac has improved a lot. Okay, so for all these standards, let's see. Actually, we have introduced this table before, and let's see some of the key points in it. For example, the maximum rate nowadays is up to 9.6 Gbps in 802.11x, right? And the interference possibility is low in .11ax. And the environmental adaptivity is very good. The modulation mode is changing from, for example, for when we use OFDM in .11a, and now in .11ax we use OFDM-A, MU MIMO for downlink and uplink, right? And nowadays standard we are using is compatible with some old versions, right? The bandwidth has improved a lot. The spatial streams is maybe up to 8 streams, okay? And the last is about the generation of Wi-Fi. Nowadays, we're using is Wi-Fi 6, right? Which is supported by .11ax. Okay, this is about the .11 protocols. And about this part, let's see a question. What are the advantages of .11ax over .11ac? And it actually is quite easy, right? All the choices here are the advantages of .11ax. Higher rates, multi-STA transmission technologies, and anti-interference, power saving, right? All of them. Okay, that's all for this part.